So for today's lesson, we are still practicing solving by substitution, but we're going to be looking for special solutions. So remember when we looked at the graphs of systems, sometimes we had one line and there was an infinite number of solutions. Sometimes we had parallel lines and there was no solution. So far, all of the systems we've solved by substitution have had one solution. So we're going to find the other two types of solutions today. So we're still solving by substitution, so that's our first step. My second equation has an x that's almost alone, so I'm going to add 6 to both sides to get it completely alone. Then I'm going to set up my boxes. So x equals 6 minus 2y, and I will replace x in my first equation. So rewriting, substituting 6 minus 2y for x, finishing my equation plus 6y equals 18. When I distribute my 3, I get 18 minus 6y plus 6y equals 18. Combining like terms, negative 6y plus 6y cancels, so I'm left with 18 equals 18. So a special solution to a system occurs when the variable disappears and you're left with just numbers. So here's how you can tell which type it is. Is it infinite or is it no solution? So if all of the variables cancel and the equation is true, it has an infinite number of solutions. Our equation is 18 equals 18. That is true, so we have an infinite number of solutions. When the equation is not true, so something like 0 equals 18, that would be no solution. So let's take a look at another one. Solving by substitution. I've got two good options here to solve for a variable. I've got y that's kind of alone in both equations. I'm just going to use my first equation, subtract 4 from both sides. So this becomes y equals 4x minus 4. So I'm solving by substitution here using my box around 4x minus 4. And I'm going to replace y in my second equation with 4x minus 4, finishing my equation plus 5 equals 4x. Combining my like terms on the left-hand side, negative 4 plus 5 is 1. And now I need to combine my x's, so I'm going to subtract 4x from both sides. So I got 1 equals 4x minus 4x cancels on both sides, leaving me with 0. Since this equation is not true, there is no solution.